Welcome back to the videos of titration. And in this video, we are going to very briefly look into redox titration. So redox titration is a set of a group of titration reactions which are based on redox reactions. So these are reactions where either the analyte is being oxidized as a result of the reaction with the titrant, or it is being reduced as a result of the reaction with the titrant. And here belong all kinds of analytes that are known as oxidizing agents or um, reducing agents. However, what is important to consider here is that this reaction still has to be very selective and has to produce with a known stoichiometry. So that means that a determination of redox reactions that do not proceed to a specific endpoint but produce various different products with different ratios varying from um, um, in varying ratios can't be used in redox titration. However, redox reactions are very widely used as well. Um, some of the examples incorporate, for example, the determination of the iron 2 plus ions, where iron 2 plus is oxidized while the titrant is reduced, and therefore the iron concentration, iron plus 2 concentration, can be selectively determined. One very, very widely used reaction is a reaction between thiosulfate and iodine, which produces iodide ions as well as tetradiene. And this is extremely widely used because iodine can be produced in reactions with oxidizing agents from iodide ions. So, for example, potassium iodide mixed with peroxides produces iodine, and this iodine can be further analyzed with this kind of redox reaction with disulfate. This is a kind of an example of a titration reaction where we don't titrate directly the analyte, but we rather react the analyte with something, and the reaction product is then further titrated. So it's like a two-step process, which is actually also often applied in titration reactions. So this kind of iodine reactions, as mentioned, is used for peroxide determination, for example, in food oils to determine if there are any peroxides formed during the aging of the oils. So to be sure that the oils are well preserved and they are still safe to use. Another redox reaction that is used often is ascorbic acid determination in juices or in vegetables. And this is also a possible example of redox reactions. Redox reactions are also quite interesting because sometimes they can be self-indication used for endpoint determination. These are cases where the titrant, for example, is colorful. These are, for example, potassium permanganate is a very often used titrant that is colorful in its permanganate form, but once it reacts, it becomes colorless. So at the moment when the analyte is completely consumed and is not reacting anymore with permanganate, then the sample solution colors the purple color of the permanganate ions. Starch indicator is widely used to detect iodine. So starch forms a black complex with iodine, and the vanishing of this black color can be used then to indicate the consumption of iodine. There are also specific redox indicators, so compounds that are not as reactive as the analyte is. So they are reacting with the titrant after the analyte, and um, therefore their reaction occurs immediately after the stoichiometric point, and they changed color due to these redox redox reactions. And lastly, also potentiometric detection can be used, similarly to the examples we viewed previously for pH detection, pH-based potentiometric endpoint detection. And here then we would potentiometrically measure the signal from either analyte or the titrant. That was shortly about potentiometry, about the redox titration.